Hello and welcome back. Today we talk about how we can handle big data with OpenBIS. In particular, how we can use a Python script to link data that is stored in external storage space to OpenBIS. So why are we talking about this again? As a reminder, in OpenBIS you can handle all the metadata and create experiments and samples and so on. But for large data sets or for big data, this is too large to handle in our OpenBIS installation. So we need to put this into an external storage space on S3 and Cosine. In order to create this link between the external storage space and OpenBIS, we need to use a Python script. So to get the script, you clone the RDM repository from our SFB and build your local environment using Poetry. Then the first step, before you link anything, you need to create the object that you want to link to, for example, an experiment. So here we have created a demo experiment. You can already see I've had a previous link already done as part of this tutorial. So we don't want to upload data to OpenBIS, but we want to create a link between the external data and this entity here, the default experiment or our demo experiment. Before we can do anything, we need to have an authorization string. So you log into OpenBIS and get this session token here. It's essentially a time-limited password replacement that you can use. So we need the following details to create the link. So we need our access token that authorizes us against OpenBIS. Then we need the OpenBIS configuration and the S3 configuration where the files are going to be. So here ask project 07 for help. You can specify an optional prefix. For example, if you want to make files unique in S3, this gives you a tag essentially that will be prepended to the file name. So for example, my experiment on something or my sample analysis or whatever you want. Of course, you need the file that you want to link and you need the identification string where to link the file to. You need to specify the type of data, and if there is a metadata extractor available for this type of data, then you need to specify that as well. And you can specify a name of the linked dataset in OpenBIS under which it appears in the GUI. The configuration file that stores recurring information contains the details about the OpenBIS server. So this you can also get from project A07 and from the S3 configuration. So this is something you always need in interacting with OpenBIS and the S3 storage space. But for you, this needs to be set up once and then you can use it all the time. So how do you get this OpenBIS ID string where you want to link it to? So you go to the entity you want to link it to, for example, our demo experiment, click on more and then there's show identification info. And then you scroll down until you get to the point of the description of the experiment where it says identification info, and then there is the identifier. That is something that is separated with 3 slashes. So in our case is /CSC 1394, then our /1394 demo, so our demo environment that you can see here also on the right. So that we are here and this is our default experiment and this is what we want to link to. And you can see here this is reflected in this identifier. Then we execute the following command with the Python script. So we run the Python command with register LinkedData, we specify the config file that we have created previously, the file name that we want to upload to S3 and link to OpenBIS. Then here object, this is essentially the object ID. The dataset type, this is the file type that we want to specify, for example, electron microscope image or EBSD image or TEM image or something like this. You want to give it a name. If there's a metadata parser for this file type available, you can specify it here, and we need to specify our OpenBIS token to authorize us against OpenBIS. Using the script automatically extracts relevant metadata if a metadata parser already exists for this file type, uploads the file to the S3 bucket that is specified in the config file, unless you specify link only if you've, for example, already done this manually, and creates the link to this object. So if you do this, and this is what I've done previously, you see that there's a test upload. I created the name, I wanted to give a test upload, right, and give it a name. And then you can see here, it was an electron microscope image, file type SE. And there's a link symbol that indicates that this file is linked to OpenBIS and stored externally. You can also see now in our default experiment, the file appears here under datasets. If we click on that file, so we go to datasets, our test upload, we can see all the relevant details. Here for this particular file type, the electron microscope images, we already have a metadata extractor, so you can see that it extracts the metadata that will come in a long list down here. That is all the metadata contained in that file. And here you have the information about how to retrieve the information from OpenBIS again. So looking a bit more detail, it's in cosine, and then this is the configuration that we specified where we go to where this file will be stored at. So we can go to this place in our cosine interface, for example, and look at the test bucket. And here is the file name. As we said, we can prepend information. So for example, this was called test image originally. Then I gave it some prefix. It will also add automatically a timestamp that helps you, if anything should go wrong, to identify when this file was uploaded. And I also prepend your username, so if multiple people write to this S3 bucket, we can at least trace down who uploaded this file, when, and what it was about. So this is like a good common practice to have a user-specified prefix as well that is somewhat related. Of course, that's redundant information, it's just as a safety measure. So if you then look at the cosine bucket, the S3 bucket, we can see here the file has been uploaded automatically and, as we've seen previously, linked to OpenBIS.